Hi guys, welcome to my online YouTube channel. Today we are going to be looking at types of vectors. Before I move on to the types of vectors that we have, I will need to explain to you what we call vector. In my last video, we talked more about different examples of vectors and scalar quantities. Vector quantities, we said they are quantities that requires magnitude and direction. Now, today we'll be looking at what fixed vector and types of vector. And also, we're going to look at how do we represent vector. Now, normally, we said vectors are pointing that requires magnitude and direction. You see, vectors can be represented with a line, with an arrow, whereby the length of the line, let me say the distance of the line from here to here, which is the length of the line, represents the magnitude of the vector. The magnitude of the vector. While the arrowhead is signifying the direction of the vector. Now, this indicates the direction of the vector, while the length of the line indicates the magnitude of the vector. I can have another vector that might be moving in different direction. That means its point of application is different from each other. Now, this is a vector, this is another vector. Let's assume that this is a vector of magnitude 2 Newton, and this is a vector of magnitude 1 Newton. So each of these two vectors have different magnitude, and also their direction, or let me say their direction in which they are moving are also different. Also, we can also represent vector in normal represent vector with a bold letter, either writing a bold letter. Let me say this is a vector A. Vector A. Why the magnitude of a vector is represented using the ordinary letter. Why? Also, we can also represent a vector by making use of an ordinary letter with an arrow on it. This can be used to represent vector, and we can also use a bold form letter to represent vector. Now, also from my definition of vector, I said a vector is a mathematical representation of quantity with magnitude and direction. Now, today we're looking at the types of vectors that we have. There are varieties of vectors which are applicable to different quantity. For instance, we have what we call a fixed vector. Now, you see, a fixed vector is a vector that is used to represent a force acting on the body, or let me say a particle. A force that is acting on the body, or a particle that is fixed at one point, we call it a fixed vector. Take for instance, if I have a force that is acting on a hook, let me assume that we have a hook that is fixed to the ground. This is an example of hook. Now, this hook is already fixed to this direction here on the ground. Then I have a force that is acting on the hook along these two directions here. If here is a force F1, which is due to the tension of the rope, and we have force F2. Now, these two forces here, they are acting on this hook here. We call this kind of force here a fixed vector. The kind of vector that is used to represent this force here, we call it a fixed vector. Also, we also have another type of vector, which is known as free vectors. You see, there are some forces that move in space. When we say movement of forces in space, take for instance, the force of couple. Now, force that is due to couple. When we say couples are two different forces that are acting in opposite direction to each other. That's what we call a couple. Now, the force that acts on it, the force that acts due to couple, is the form of a free vector. Now, how does it take place? If I have a couple that is acting on the material here, let me say this is one force here, another force here. One of the major effects of a couple is that it tends to cause rotation of the body, either in circular manner. It rotates the body in circular manner. So a vector that is used to represent a couple is also called a free vector. Also, we also have what called a sliding vector. You see, normally if I have a rigid body, this is a rigid body for instance. Now you see, if a force is exerted on this body to move this body has the ability to slide in the rightward direction or to slide in the leftward direction due to the application of force on the body. Now, you see, the vector that is used because this body will change its position along a single line. Let me say we have a body that is at rest here. Now, if the movement, or let me say the line of action of the force should be along this direction, I can exert a force on this body this is a rigid body. I can exert a force on this rigid body to make it slide from this position to under what? New position in this place here. So if the body moves from here to here, now this force that causes the movement, or let me say that causes the sliding of the body from one point, from this initial position to this position here, we call it a what? A sliding vector. It is a sliding vector. Why? It is used to represent what? The force acting on the what? Rigid body. Now, that is moving. That can what? Easily slide in space. Now, we also have another type of vector, which is known as equal vectors. You see, two or more vectors are said to be equal to each other if they have the same magnitude. Now, they might have the same magnitude. It doesn't matter if their point of application is the same or not. They might what? So, equal vectors are vectors that have the same magnitude and the same direction. They might have what? Different points of applications. Take for instance, two or more parallel forces are said to what? Equal with each other. Their point of application might be different, but they have the same, they are moving along the same direction. If I have what? This is a parallel force. Sorry. I have a parallel force. So this parallel force here is a kind of what? An equal vector. Why? Because the magnitude of this is equal to the magnitude of this, and is equal to what? Magnitude of this. So we also have a negative vector. See, normally when we say the negative, some feel somehow that what? Negative vector. Is it possible to have a vector that is negative? Yeah, it is possible. It is possible to have what? A vector that is. Why? Because a body can move in different, for example, I can have two different vectors that are moving in opposite direction to each other. Now, these two vectors, if they are of equal magnitude, they create what we call a negative vector. Now, take for example, so let me say I have a vector P. Let me say I have a vector P. Oh, I have a vector P. This is a vector P. The vector P is towards this direction. If I can draw another vector that has equal magnitude to P, that is, the vector has equal magnitude to P, but it is moving in what? Opposite direction to that of P, then this vector should be what? The negative of P, which is what? The negative vector. Now, we can have also a null vector. That is a zero vector. You see, as I said earlier, you have equal vectors. You can also have a null vector. That is number 6, null vector. When we say null, non-vector, simply means a vector that has zero magnitude. Vector that has zero magnitude. How do we get that kind of vector? It simply shows that what? A null vector should be a vector with equal magnitude, with what? Equal and opposite, with equal magnitude, but in opposite direction. It is a what? Null vector. That means, what differentiates between this null vector and this negative vector? For a negative vector, we are referring to a single vector, but we can change its what? Direction. A single vector that we can change what? Direction. That's what we call negative vector. I can easily say that what? My vector P, let me say this is my vector P, minus of what? Is what? Opposite direction, which is minus P. Simply means my vector P, if these two vectors is added together, vector P plus bracket of negative of what? Vector P in opposite direction can easily give rise to what? A zero vector. Thank you for watching. Always have a nice day. Please don't forget to subscribe to my YouTube channel to get more videos of this kind. Thank you.